Assalamu alaikum.
Walaikum salam.
So today we will finish lecture 6, and if we finish early then we can start 7. I sent out an email about the midterm. The midterm inshallah is going to be on Tuesday. It will be on lessons from 1 to 6. So this lesson that we're finishing today is included. Assignment 2 is extended until tomorrow night. Try to do it several times. If you have questions, send me a message, okay? Then quiz 2 is going to be on Saturday. And on Saturday, I'm going to open assignment 3, which is on lesson 5 and 6. But quiz 3, it will be after Tuesday, so it will be Wednesday. Okay, now, lesson 6 is about Norton's equivalent circuit, and the theorem says that any equivalent circuit with 2 terminals, okay, we can look at those 2 terminals and find the total resistance and find the short circuit between those 2 terminals. And based on that, we can find the equivalent circuit, which is going to be only a resistor. We call it Norton equivalent resistance, Rn, and a current source connected in parallel with it. And this current source will have a current of In, the Norton current. And this is equivalent to the circuit if it's a linear circuit with 2 terminals. Now, those are the 2 terminals here. So what is between the 2 terminals not included in my circuit. So that R1 is not included in my circuit. It's just added. That is considered a load. It's external to the circuit. So when we want to find the equivalent circuit, the Norton's equivalent circuit, we have to find 2 things. Rn, then we're going to find In. Even here, I'm going to write it as to find. These are the 2 things that we have to find equivalent circuit at the end. So we're going to find Rn. Now there is a circuit for Rn. There is a circuit for In. In is a short circuit current. It means it's a short circuit between the terminals. So I draw the same circuit until I get to the terminals. I make a minor change there. So this is the circuit. These are the terminals. This is the circuit that I want to find the equivalent for. So this is 50 ohm. This is 50 ohm. This is 150 ohm. This is the 120 volt. Okay, so this is the circuit that I want to find the equivalent for. I'm going to draw it here, the same circuit. Should have terminals. So this is 150 ohm, 50 ohm, 50 ohm, and 120 volt. See the 2 circuits. This is the circuit that I'm going to find the equivalent circuit for. Now the changes that I should make when I want to find Rn, I don't want the sources, so I'm going to remove the sources. Remove the source. What I replace it with, if it's a voltage source, I'm going to replace it with a short circuit. So I'm going to put the short circuit here. And this is where I find Rn. So this is the change I make because I want to find the total resistance. I don't want sources. I'm going to remove them. When I remove them, I should replace them with a zero value. So if it's voltage, the zero voltage is a short circuit. If it's a current source, the zero current is an open circuit. Now, the second thing, when I want to find IN, it is by definition, it's the short circuit current. So I'm going to put the short circuit and I'm going to say this is IN. So this is what we learn in this theorem, that we have to find equivalent circuit, which is a source, current source in parallel with the resistance. We have to find the circuit that will give me the Rn and the circuit that will give me In. This is very important. This is like 50% almost of the question. Now, the analysis and finding Rn and In, that is, it's going to depend on your abilities and how big is the circuit, how difficult is the circuit, what technique you're going to use. Now let's do the Rn. So this is the circuit. I'm going to try to redraw it in a nicer way. So I'm going to put this. I'm going to put this. This is here. The two terminals, I'm going to just move that terminals until here. So this is this terminal, the first one. The second terminal, I'm going to just put the point here, which is the same like this. And this is Rn. This is 150. And this is 50. And this is 50 ohm. Now this is exactly like that circuit. It's just this point here is the same as the point here. So I just draw it here instead of all this. So not to confuse myself. Now I need to find the total resistance between these 2 points. Now 50 and 50, they're connected in series. You can see they're in one single branch. So I can combine them. So these two, I can combine them into one resistor, which is going to be 100 ohm. It's just the sum of these two because they're connected in series. Then everything else is still the same. $150 ohm, and this is Rn between these 2 points. Now the 150 and the 100 are connected in parallel, so basically Rn is going to be the combination of 150 and 100, so you multiply 150 times 100 divided by the sum. This is an easy way to find the total resistance. If you have two resistors, you just multiply, you divide by the sum. So this is going to give you 60. So this is 0 ohm. So I found this is 60 ohm. Is it okay so far? Any questions? Any questions about the procedure? Try when you solve this kind of questions, try to do the same thing. Draw the final circuit and say, okay, this is what I want. Okay, draw the circuit that, or the network that you need for Rn, the network that you need for In, and you have to remember that Rn is only total resistance, so no sources in the circuit. In is the short circuit current between the terminals, okay? So we're gonna put the short circuit and find the current here. Now to find the current in the circuit, you can use any technique you want. But I think the easiest would be just trying to find the total resistance, then find the current in this branch. So this circuit, if I want to simplify it, these two resistors, I'm going to combine this and this, so they're actually 100. This is still 150. This is my current In. It's here. and this is the source. 120 volt. And these two resistors, I'm going to combine them into one resistance. These two in parallel is going to be going to give me 60 ohms, so it's going to be 60 ohm. IN is here, and this is the source. So this is 120 volt. Now in this circuit, it's quite simple to find the current. Is just the resistance divided by the voltage divided by the resistance. So it's 120 divided by 60 Ohm's law, and this is 2 ampere. So what is IN here is 2 ampere. Now I found the equivalent circuit. This is the Norton's equivalent circuit. So this is the answer of this question. Any questions? Any questions? Yes, no, easy, difficult? Any feedback? Okay. No questions, so it's fine. Okay, thank you. Okay, now I'll give you a few seconds so you can actually take a screenshot of this or you write it down before we move on. Okay, next exercise. Try to do this while I'm gonna take the attendance. So try to do this exercise, the same idea, but it's AC now. So remember, you're dealing with an AC circuit, so you're we don't need the voltage in Norton circuit. No, Norton equivalent circuit, what it says, here's what it says. 1 second, so I'm gonna go back. This is the theorem here. So any network is gonna be replaced by equivalent circuit, and this equivalent circuit is a current source parallel with the resistor. So this is the equivalent circuit. So this is what the theorem says, that any network at the end, it will have equivalent circuit looks like this, which is current source and resistance connected in parallel with the current source. So this is the theorem. The theorem doesn't say voltage source is connected or anything. It says this, that we can actually find equivalent circuit, which is only IN and RN. So whenever it says find the Norton equivalent circuit, what you need to do, you need to find at the end the current source and the parallel impedance in this case, because it's AC. We have an impedance here. So I'll give you, try the question, please, while I'm going to take the attendance. Today is 27th. Okay, so Abdullah Khalid, if you're around, just say yes, or if you're, you can write that. Abdullah, you're around? No? Muhammad Mohsen? No? Hassan? Hassan Abu Hassan? Rand?
Yes.
Thank you. Yazan?
Yes.
Thank you. Sarah? Sarah's not here. Abdullah Ali?
Yes.
Thank you. Maryam?
Here, mister.
Abdullah Ahmed? Abdullah's not here. Ahmed Al-Tayyib? No. Khalid? Ali? I think Khalid dropped the course. Asma? Thank you. Muhammad Yusuf?
Yes.
Thank you. Lean? Thank you. Fahad?
Yes, sir.
Thank you. Amal?
Yes.
Thank you. Abdullah Hassan? Abdullah Hassan is not here. Hazim?
Yes.
Thank you. Samar?
Yes, mister.
Thank you. Ziyad Ali?
Yes.
Thank you. Awatif?
Yes.
Thank you. Isam?
Yes, sir.
Thank you. Manal? Thank you. Hamad? Hamad's not here. Asia? Thank you. Sharif? Not here. Ahmed Ayman? Thank you. So the guys who are not here, Abdullah Khalid.
No, sir, I'm here.
Okay, thank you. Did
Welcome.
not hear you the first time. Muhammad Mohsen, Hassan Abu Hassan, Sarah, Abdullah Ahmed, Ahmed Al-Tayyib, Khalid Ali, and Abdullah Hassan, Hamad, and Sharif. Those guys are not here. Okay, go back to the lecture and continue. Okay, so AC circuit, at the end, the question says find the Norton equivalent circuit. So I'm gonna tell them, okay, here's the Norton equivalent circuit. Do you want it? And I'm gonna draw it first. Make sure I get some mark, even if I do nothing. Now it's AC, so I'm gonna have impedance, and I call it Zn. Going to have a current source, and it's AC current source. If you leave it that way, it's okay. If you put the squiggly sign just to show it's an AC, that's okay. So this is IN. They're connected in parallel. They have terminals, and those terminals are similar to the original circuit terminals. So this is A, this is B. What is between those terminals is not included in the circuit, so that guy ZL is the load here. This is just ZL. So ZL is not actually part of the circuit. I want it here for these ones. So I have to find two things, Zn now. So I need to find Zn. And I need to find In. Once I find these two, I can plug them in my network, the equivalent circuit, then I can say, okay, that is what we have. So finding Zn, I'm gonna draw the circuit. Capacitor, resistor, source. Between here I have a branch and its inductor. So this is J8 ohm. This is minus J8 ohm. This is 10 ohm. This is 120 angle 0 volt. And those are the terminals. This is the circuit that I'm looking for equivalent for it. A and B. The same circuit here. Go. The impedance, resistance, source. It's an AC source. 120 angle 0 volt. Then there is a branch in between here and it's an inductor. This is J8 ohm. This is minus J8 ohm. And this is the 10 ohm resistance. Those are the terminals. Now see, this is the same circuit I draw here and here. This is A, this is B. Now the difference, when I want to find Zn, I'm gonna remove the sources and Zn is gonna be here between the terminals. I'm gonna look this way. Look to the circuit or into the circuit from the terminals, and I'm gonna remove the source. It's a voltage source, so I'm gonna replace it with the short circuit. So this is the circuit that I'm gonna use to find Zn. Now to find In, it's the short circuit current. So I'm gonna put the short circuit here between these terminals, and I'm gonna say this current here is going to be In. So I got the circuit that I'm gonna use for finding Zn, and I got the circuit that I'm gonna use for finding I'm going to use for finding In. Now the rest is circuit analysis. The concept is already there. I put all my concepts, the idea of the theorem. Now I'm gonna try to make the circuit look nicer. So this one here, that is this resistance, that is this inductance, that is like that. Those are the terminals. This is Zn, looking between these 2 points. This is minus J8. This is J8 ohm, and this is the 10 ohm. I just put this is one branch. I put it here, just here. It's the same. If you go through this branch, you're gonna face this resistance. Now I can see that clearly these two are in parallel. So I want to combine them into one impedance. Then what I have left is the same thing. This capacitor and this is Zn. And this is minus J8 ohm. Now to find this, I have to do these two in parallel, which is I'm gonna multiply them, divide by the sum. Can anyone put this in the calculator and give me the answer? And by the way, once you find that, you can just add this one to it. So Zn, this one here, which is that answer, I can just write it 10 J8 divided by the sum 10 plus J8. And this is added to this because they're connected in series. So plus minus J8. And this should give me the total impedance. And I want you to help me and find this answer. Plug it in your calculator. Give me the final answer either in the polar form or in the rectangular form. 4 minus J4. Are you sure? So I got 4 minus J4. Ohm. So can write it here. 4 minus J4 ohm. Now if someone writes this like this, 4 is resistance, 4 ohm resistance, and capacitance, which is minus J4. 4 minus J4. So this is all Zn. So if you write it like that or you write it like this, it's both are fine. Let me look at the end, the answer. No. No. There's something maybe missing. The answer here is 5. Can you guys repeat this one more time? Plug it in your calculator and find the answer, please. I'm just gonna write the answer that I got in there. So this is gonna be different and this is gonna be different. Yeah, that is 5 minus almost. So 4.998. So it's 5 angle minus 38.7. So I'm gonna put that number here, 5. Make sure you do the calculation again and again. Minus 38.7 degree, and it's in ohm. Try to do those questions on your own and do the calculation on your own and use the calculator to get the right numbers. Minor mistakes are kind of accepted in the midterm, not really in the quiz and the assignment because you have to write the right number. Okay, now this is the first one. Now we're gonna do the IN. To find IN, this is the circuit. I can use any technique. I'm gonna use nodal analysis. So this is my node here, V equal to 0, and this is my node V1. Anything connected to it, this is the node. And this is the node here. Those are connected to it. I'm gonna redraw the circuit. I'm gonna redraw the circuit in a bit nicer way. In a nicer way, let me just, okay, so this is the circuit. I'm gonna put the capacitor here. which is in the same branch. And this is the source. Oh, I forgot the resistance. There's a resistance there. That 10 ohm resistance. So this is 120 angle 0 volt, 10 ohm, J8, and this is the minus J8. IN is the current going here through this. So this is IN here. This is IN. This is the ground, and this is the end. This is this node here. V1. And this is this node here, the reference V0. I'm doing nodal analysis. 3 currents. So this is leaving this way. I'm going to say it's I1. This is leaving here. It's going to say I2. This current going that way is IN. So I just write it's IN. This is what I want, this current IN. Right, going through the capacitor, then going through the capacitor, going through the short circuit to the ground. So 3 currents, they're all leaving. So 0 equals the leaving currents, I1 plus I2 plus IN. From here, I'm gonna 0, write the voltages, V1, current is leaving the node, so it's V1 minus the voltage here, which is 120 angle 0. So V1 minus 120 angle 0 divided by 10. Voltage divided by the resistance plus, I'm gonna finish it here, maybe this is space. V2 is V1 minus 0. The current I2 is the current going here, so it's the voltage across the inductor divided by the impedance of the inductor. Impedance of the inductor is J8. Then this is this ZIN. It's the voltage minus 0. The voltage at this side is V1. The voltage at this side is 0 divided by the impedance, which is minus J8. This is IN. Remember, this is what we want. This is the important guy that at the end that this is what we want. It's IN. Now, here to solve this equation, we're going to get 0 equal to V1 minus 120 angle 0 divided by 10 plus V1 over G8 minus, this is minus V1 over G8. This is V1 over G8 and minus here. I put the minus up here, and this is V1 over G8. These two cancel out. V1 over G8 minus V1 over G8, they cancel out. So I have 0 equals to V1 minus 120 angle 0 divided by 10. Multiply both sides by 10, so I get 0 equals to V1 minus 120 angle 0. So V1 equals 120 angle 0 volt. This is the voltage. Now I don't want the voltage, I want the current IN. IN is the current going through this capacitor through the short circuit. So it is the voltage across the capacitor, which is V1 minus 0. The voltage at this side is V1. The voltage at this side is 0 because it's connected to the ground. Divided by the impedance minus J8. So this gives me 120 angle 0 minus 0 divided by minus G8. And that is going to be 15 angle 90 ampere. So at the end, the answer here is 15 angle 90 ampere for this current, and this is the answer. Is this question okay? Any question here? You see, the procedure is the same. It has some details in the middle. Those details might be confusing, might seem easy, might seem too difficult, but with the practice, you're gonna master it. So those exercises, there are 5 or 6 in every lesson. Go do them on your own, then you look at the answers. Then when you have assignment, do the assignment several times. And it's normal that you get a low mark at the beginning, because without the practice, you're not really, you have some basics, but you still make lots of mistakes. Any questions here? Any questions? Okay, so I'm gonna go to the last exercise, which is this one. So the same idea, we're gonna find the Norton equivalent circuit. So at the end, I'm gonna say, okay, this is the Norton equivalent. So this circuit is equivalent to the original circuit. Equivalent to it means we'll do the same thing. We'll give you the same current, the same voltage for whatever load. And XC is the load here. So it's going to be A and B, the points. Those are the terminals in the original circuit. So I have the same terminal in the equivalent circuit. I'm going to have an impedance, and it's called Zn. I'm going to have a current source, and it's called In. Now, why do you have impedance? Because the original circuit is AC. So the equivalent circuit has to be AC as well. And at the end, I'm going to connect my capacitor between these two. That is the load in this case. And it's XC equals to 32 ohm. So that XC between is not included in the equivalent circuit. And even here it says find the equivalent circuit for the network external to. So not the internal thing between the two terminals. So I'm going to find two things. Zn, not Rn, now it's Zn. And I'm going to find let's just say find In. I'm going to draw the circuit for each one of them. So the circuit here, those are the terminals A and B. At this side I have resistor, inductor, and the other side I have a resistor R2. This R2 is 68, and this is a 20 ohm, and this is J20. Remember, we use impedance, so we have to put the J thing when you have inductor and capacitor. And we have the source here. So this is the circuit. I'm going to do the same circuit here. We have the source, and it's 10 angle 0 ampere. Then I have this branch, a resistor, inductor, 20 ohm, J20 ohm. Then I have my the circuit, the terminals. This is A, this is B. Then I have this here, resistance. 68. Now, when I want to find Rn, what do I do? Remove the source. So I'm gonna remove the source. It's a current source, so I'm gonna leave it open circuit. I replace it with an open circuit. Now here in this circuit, I'm gonna put the short circuit, and I'm gonna say I'm gonna find the current here. Now the analysis, I'm gonna simplify this one. The open circuit branch has nothing there, so that is open circuit is not gonna affect the open branch. Actually, is not gonna open a branch. No circuit open branch is not gonna affect my total impedance, because impedance and there's infinity. So this I can draw it. These are the terminals A and B. Between the two terminals there is this resistance, which is 68 ohm. And if you keep going, there is a resistance in parallel with the inductance, and these guys is 20 ohm and J20, J positive, not negative. J equals 20 ohm. So this is the circuit, and this is the impedance Zn. Looking this way. This and this is the same circuit. So this a branch, we remove it from the circuit because it's an open circuit. The branch is not going to affect these 2 points, which is the point here and here. I can put them here, the same points. I can put them this way. It's the same point. This is connected here, terminal A. This is connected here, terminal B. Now the 20 and the 20 ohm inductor, the 20 ohm resistor and 20 ohm inductor, both of them are connected in series, so I can combine them into one. Then this is here, and this is the terminals Zn. 86. Now when I combine these two together, they're just 20 plus J20. Just add them. They're connected in series. So Z now here is the two elements in parallel. That one is 20 plus J20. I don't leave enough space for some reason. Multiplied by the 68. Then it's 20 plus J20 plus the 68. Now this should give you an answer at the end, and I think it's 21.3 angle 32 ohm. So this is a 21.3 angle 32 ohm. Done with this one. Let me check the answer just to confirm. 21.330. Okay. Now here in this circuit, look at the 68 ohm. There is a short circuit around it. So any element that is short, remove it. So you can say, okay, here's what I have. Oops. Okay. Why? This is shorted. Look at the terminals here. There is a short circuit across them. Now the same thing. These two, they're shorted, so the circuit will be like this. So from here, IN basically is just 10 angle 0 ampere. So this is 10 angle 0 ampere. Any branch that is shorted is basically removed from the analysis. Okay. Now this is the end of this question. Remember, any element, doesn't matter, impedance we mean, or resistance. If it's shorted, this will equal to this. The reason that the impedance of the short circuit is 0, the impedance of this guy is just whatever Z. When you combine them, they're in parallel, so you multiply 0 by Z, and you divide by the sum, 0 plus Z. So this will be 0 over Z, which is going to be 0. It means this combination will give you a short circuit. So if you take these two in parallel, you get a short circuit. Then this and this in parallel will give you a short circuit. So this is the total. So this current going from here, it's not going to go through this branch because there is impedance. It's not going to go through this branch because there is impedance. It will choose the short circuit and go all through the short circuit because there is no impedance. Any questions here? This is the end, by the way, of lesson 6. We're going to start lesson 7 after some time. Lesson 7, okay? Today later, and the lesson, I think it's on D to L. Any questions? No? I got one question here, says the midterm, is it gonna be multiple choice question or writing answers? It's gonna be mostly writing answers, so analyzing calculations. Maybe there is no multiple choice at all. I think we'll have no multiple choice at all in the midterm. Everything is just you go, analyze. Yes?
Sir, the midterm will be online or on campus?
On campus. I'm gonna send you the rooms, okay? I booked actually the rooms. I'm gonna divide the students on the rooms, okay? So I'm gonna send you your specific room. And I'm going to make sure that I get enough invigilators. So that is the thing that I'm working on right now, but the rooms are booked and it's gonna be on campus, inshallah. Any questions? All good, do your best. Do your best.